Matt, welcome.
Hello there. Thank you for having me.
How are you doing?
I'm doing okay, I think. I'll tell you in an hour.
Okay, all right. So we asked all our speakers, as many of you know, for the fun facts, and I did not know this one about Matt. His most popular plugin was an April Fool's Day joke that added Clippy to ReSharper, and it actually worked, right?
It did. That's the that was the best part of the joke. People saw the blog post and thought, haha, that's very funny. And it's like, no, download it and use it. And it actually did pop up and it says, looks like you're doing a refactoring. Can I help you with that?
Amazing. I need to see that another time.
Yeah.
Okay.
Highlight of my career.
I miss Clippy.
No, you don't.
So for our audience today, Matt's talk, he makes the point that working from home is here to stay. And if you're at home, then your IDE needs to work remotely as well. So the question that Matt has asked, and I hope is going to answer in the next hour, is how do you take an IDE platform that is over 20 years old, cut it in half, and then have half on a remote server and half in your home office? So Matt, over to you. Let me add your slides to the stream and I will remove myself. Have fun.
Great. Thank you very much. So yes, hello everyone. I'm Matt, developer advocate here at JetBrains, and I do work with the remote development tooling, as well as the collaborative editing tooling, and as well as a whole bunch of other stuff. And yes, we're going to talk today about how we've made this possible. And I say we, I'm going to have to say right up front, I'm going to say we several times this. I'm not involved with this. The team have done a fantastic job with this. I'm a developer advocate on these. I haven't done any, they let me develop on some things, but not on the remote development tooling. So if I say we, please excuse me, I mean the team. They're awesome. Okay, so next slide then. Right, there we go. Before we kind of dive in too deeply, I guess it's like, why remote development? Why collaborative development? Why are we talking about this? Why is this a thing? What's the what is the sort of the big selling point about all of this? And remote work, obviously, in recent years has got much more commonplace. We are doing a lot more working from home, but also working from different offices and so on. And we've got different tools then to sort of work with that with your JetBrains IDE. We've got Code with Me, which is collaborative development, and Gateway, which is a feature for remote development in different JetBrains IDEs. So Code with Me is all about the sort of collaborative development. It's not just collaborative editing, but it's the whole life cycle, debug, testing, and source control and everything. And this is great for sort of pair programming while you're working from home, but it has more uses above and beyond that as well. You don't have to be using it remotely there. You can use it in the office as well for mentoring type facilities. You can have more than 2 people on a call there. You can have up to 100 people in a session there. So mentoring is great. You can do mob programming where you get the whole team involved to try and solve a problem or to learn a new feature or to do a code review and stuff like this as well. Remote development is a slightly different scenario there. This is where we put your the IDE, the source code, the tool chain, the dependencies, everything you need to develop on a remote machine. This all lives somewhere in the cloud, for example, or in a server in your company, and you get to use the power of this remote machine there to do your actual your coding there. And there's lots of good reasons for wanting to do this. One of which would be sort of very useful from a company's point of view is to make sure that your intellectual property is secure. It always stays on the remote machine. If you take your laptop down to the coffee shop and you accidentally lose it, then you don't need to worry about it because, well, I mean, you still need to worry about it, but you don't need to worry about the source code that's on there. That's all still safe on the remote machine. You're kind of very portable. You can move around. You don't have to be tied to a desktop machine to work with that. You can scale up and down with the power of the machine that you want to use. And we've got reproducible developer environments. And this is a big deal. We can actually sort of, in the same way that we can do reproducible production environments, Docker containers and so forth, we can do that with development environments as well. We can have those built on a continuous integration type system. Every time there's a check-in, refresh those, get your source up to date, and you can even do interesting things to make sure that your tool chain and everything is built so it's very quick to switch between branches, switch to new latest versions, and so on. And this is really now starting to kick off because we've got the whole ubiquitous, reliable cloud computing these days. Networking, latency, and so forth is a whole lot better these days. So I'm going to spend some time talking about the different, how we've made this work with IDEA. But let me just give you a very quick look at what it is that we do with Gateway and Code with Me. So if I just swap over to my screen now here, this is Gateway running here. Gateway is a little application. It's all you need to have installed on your machine to get started. And there's several different ways you can connect to a remote machine there. We can do it directly through an SSH connection. So basically Gateway saying, give me a server, I don't care which, as long as it's got SSH on there, I'll deal with everything for you. Or you can use JetBrains Space as a development environment for one of the projects maintained by Space, and Space can then sort of maintain the development environment for you. And we've got other providers as well. So Gitpod, for example, there. Gitpod can also, you can install a plugin there and connect to your Gitpod spaces and work with those. If I go to SSH here and down the bottom, we can see that I've got a connection already to an AWS instance, which is just running Ubuntu. And I can click that and it'll just start up my IDE on the back end there. So I don't have anything about this project installed locally. I'm just running everything kind of in the cloud here. And what happens is that Gateway is responsible for talking to the remote server, making sure everything's up and running, and it will then start this JetBrains client that we've got. Now, this immediately looks very familiar here. It's got the project view. You know, we can navigate around and look at your source files. For example, you can see what's going on and navigate around. You got your editor. We can do search everywhere and just start typing and navigate around. We can look at what's in the file there and go to quickly jump to methods. We've got the gutter icons. We've got syntax highlighting, code folding, all of your usual sort of tool windows that you'd expect there. I've got my terminal here as well, so if I can just do host name, it'll show me that I'm running. Yes, IP 172.3.1.4.5.6.2. That's one of my favorite servers. That one is. We got, notifications window. It's basically like running a local IDE, but all of this is happening remotely. I don't have any of these files on my local machine. All these files are living in this AWS instance that I've got running. And I can run this. In fact, let me just select the right run configuration. There it is. If I click run, I can run the application, and because we're running as a remote development environment here, that will not actually, that will of course be running the application on my remote machine, and I can't use it locally. So what happens is we recognize that we're using ports, and we can forward those ports and open them in a browser, and we jump to another screen now. We can see now we've got my Spring Pet Clinic up and running there. Let me just, zoom back to those. And yes, so that's a very, very quick view of what's happening with Gateway. There's a whole load more stuff I could talk about. I'm going to sort of skip over that now. We'll talk about some sort of behind the scenes stuff. So just close this down. And now if I head over to a local version of IntelliJ that I've got running here. So I've got IntelliJ running here. It's the 2022.3 EAP. And by the way, if you haven't tried the new UI yet, you should do so. It's looking very nice and clean and lovely. But this is IntelliJ that you know and love, just using the new ID UI. We've got a button in the toolbar for Code with Me. I can just very quickly click on that, start a session. I get options for permissions, and I can sort of decide who has full access to everything. Click Start Session, and that will then start a sharing session, which I can then use to join. If I just start a browser, bring that back over here, I get a link which I can send to somebody over, chat or whatever, and that will then kick off the client to actually join and start a session. There we can see now I've been notified that this is security code 4702. It's the same on both. If I accept that, then we get the client starting up, and we can now see we've got the same sort of features that we had with Gateway running a remote server against a remote server. We've got that now for running against somebody else's code. So you can see I've got the same project model going on here. I can view all the files that are there. And in fact, if I want to look at the the same editor window as is in here, I can just click the M button here to say, well, show me where Matt is. And that will then hopefully, there it is. We can see now we've got, we can see where each is there. We've got our own independent text editors, text cursors. I can then start typing and go, hello from Matt. And then if I swap back over to this window, I can say hello from other Matts, and put out of there. You can see we've got sort of collaborative editing going on there. And as I say, we can do more than that as well. We can do debugging and testing and so on as a collaborative tool as well. And it's that easy to get started as well. You just use the button. If you're using the current UI, the button's in the toolbar here like this. If you're using the new UI, it's in the toolbar up here. So let's just end that session. And let's switch back to slides. Okay. Okay, so very, very, very quick look at Gateway and Code with Me. There's a ton more things I could show you. If you want to have a go, it's they're included in your license. So as long as you've got a licensed version, you can just give it a go yourself and see how you get on. So please do that. But we want to look at something a little bit differently now. So some key takeaways I want to take from that, though, is that we've got very different features there. You know, one is talking to a project hosted on a remote machine, and the other one is joining an existing IDE running on somebody else's machine. And so they're very different sort of from a feature point of view, but technically they're very similar. They're doing a lot of similar things under the hood. They're actually using the same client there. So that JetBrains client that was running there, this version, it's a stripped down version of the IntelliJ platform that is the same on for both of them there. And so they're both developed by the same team there. And in fact, you can kind of consider as well remote development. It's very much like a Code with Me session with just a single guest without a host either. So there's a sort of certain similarity. If you squint at it, they kind of look pretty similar there. It's worth pointing out at this point as well that remote development is in active development right now, and it does not have Code with Me support, although that's kind of something on the roadmap. A whole bunch of things I'm not going to be talking about in this talk here. It's mostly server-side stuff. So for remote development, there's a whole piece we can talk about on orchestration, on how you build your environments, pre-built environments, warming up the scripts to make sure that the indexes are up to date before you even start it. With Code with Me, the server, excuse me. With Code with Me, the server-side stuff for lobby servers and how to join a session, relay servers peer-to-peer, NAT traversal for how you talk to each other, encryption, and so on. I'm going to skip all of that. There's lots of information on the websites. It's very important, lots of information on the websites for that. But today I want to talk about something a bit different, and it is, how do we take a 21-year-old desktop IDE and make it remote and collaborative by default? This is a tricky kind of thing. And your immediate reaction might be, well, why don't we just use remote desktop? Why don't we just use something like that, which will allow me to run the IDE completely on another machine and just show me the UI as normal? And in fact, we've kind of got a solution which would work with that. It was a product which we call JetBrains Projector, which we're kind of deprecating in favor of Gateway as a much more strategic solution there. And it's a fantastic piece of technology. It allows you to work with the Swing UI that JVM applications run on, and it sort of intercepts all the graphics calls and puts those over the network. And then it takes the inputs, the mouse movements, key presses and so on, and sends those back over the network to allow you to sort of round trip and get updates. However, that's therefore quite heavyweight. So you've got quite a lot of network traffic going on, and that introduces latency, and it's not the sort of scenario and the experience that we want you to have. Excuse me. More importantly, it doesn't handle specific remote development scenarios. So if you run the IDE through Projector, the IDE has no idea that it's running in remote development. And so there's specific scenarios such as port forwarding that aren't catered for. With the remote development feature that we've got in the IDEs now, we recognize when the IDE is your application is running remotely. And we look for ports being used and offer to forward those automatically. And this also doesn't handle collaborative scenarios at all either. So we need something different. We need a more a different scenario going on there. And it kind of makes one of the decisions for us here as well, is that we're going to need a local client. So we don't want to just sort of show the user interface that's running on the remote machine. We're going to need a local client. So we should back up a little bit and see what some of our requirements are. And we've got some which are sort of feature specific here. So if we're talking about remote development, we want to be able to run the IDE on a remote server, and the source and the development dependencies and the tool chains all run there. We run and debug and compile and everything on the remote machine, but we want to be able to access all of that, including testing the application locally. So we need to be able to sort of split things somehow. We also want the full IDE feature set to be available. So we want to be able to use all of the IDE when we're doing things remotely. We want it to be OS agnostic. So I don't want to be, I want to be able to sit on my MacBook and use developer against a Linux server. Remote development currently only works with Linux servers. We're going to be supporting other operating systems as we go forward. But right now, I don't want to have to be using a Linux laptop to work with a Linux machine. So I want it to be operating system agnostic. Also, we want it to be no local IDE necessary either. So we don't want you to have to install JetBrains IDE to be able to use a remote IDE. So we want everything to be managed for you. And that's what Gateway does. Gateway manages that for you. Code with Me has slightly different requirements. We want to be able to connect to another person's IDE, not to a remote server. So there's going to be somebody interacting with that IDE currently, and we need to be able to work with that. That means there's going to be multiple people editing the files at the same time, and therefore we need to have some sort of we need to make sure that's conflict free. So if somebody's changing the same line at the same time, we need to be able to handle that. So think of Google Docs but with IDE features such as code completion and so on. We want to be able to put permissions and restrictions on guests so that they can't just run everything. I'd hate to let everybody use the terminal on my machine just because we're sharing a screen, sharing a session to help me edit code. And also it's important to point out that guests don't need the full feature set, the full UI. If I'm a guest in another person's IDE, I don't need to be able to change their settings. I don't need to be able to change the project setup or the version control bindings. So I need a reduced, restricted feature set there. And that is actually sort of one reason why we started building Code with Me before we graduated onto building the remote development features. We also want Code with Me to be OS agnostic as well. We have some cross-cutting requirements. So we want to be able to deliver an experience which is as good as or better than local development. We can make it better than, because if you're using a laptop, you can ideally be using a less powerful laptop and a more powerful cloud machine, and be able to then get a better experience because you can have much better compile times and everything on a beefier machine in the cloud. But we also want you to be able to customize that local experience as well, themes, key maps, plugins, and so on. It kind of needs to be built into the platform here. We can't just sort of bolt it on the side. The platform needs to understand what's going on here. And one of the big requirements as well is that it doesn't involve a grand rewrite. We don't want to have to rewrite the entire IntelliJ platform to be able to support remote development or collaborative development. That means it needs to be as general purpose as possible. If it can solve, we don't want to have to solve feature by feature. If we can, for example, inspections, if we can make one inspection work, we can make all inspection work. And therefore, if you add a new inspection, then it should just automatically light up and be brought in. We also want to be able to support third-party plugins as well. In fact, the IDEs themselves are built as plugins, so we've got a lot of first-party plugins in there. So we don't want to have to rewrite lots of code just to be able to work with that. So we have a core proposition which opens up some obvious problems. We want to decouple features from the UI, but we don't really know where that split should be. Where, what is the local UI? How much, do you want a thick client or a thin client? How does that work? We've got problems. The IntelliJ platform itself isn't designed for this. There's lots of synchronous APIs, whereas working remotely, you're going to be doing lots of async work. We want to run the IDE as a server, but what does that mean? How do you mean by server? It's not a website. It doesn't work like that. It's a very different sort of beast here. We've got a lot of state being maintained. So we're doing that, but then also how do we handle multiple processes? The IDE right now is basically a single process. So how do we scale this out? As I mentioned, concurrent editing. We want to work with conflict resolution so that multiple people can edit the files at the same time. And we need to add additional functionality for remote or collaborative scenarios. If we take a look at one of those, then synchronous APIs. We're working with a 21-year-old desktop IDE here. It's got a lot of APIs in it, and a lot of features, and the constraints and requirements for this desktop application aren't the same when we're running it, when we kind of split it across and run across different boundaries. But the problems we get with it kind of depend on where we split the IDE. So if we want to, so we can imagine that various synchronous APIs are going to have sort of entry points at the user interface. And so we could make those into sort of async boundaries there. And then all the internal APIs being synchronous is okay because that could run on the server. But if we wanted to split things inside that boundary, then how would we work with that kind of thing? We could refactor stuff, but we want to avoid the grand rewrite and having to drastically change the architecture of the product. One way we can do it, and one which has proved very effective, is that we can handle this with smaller, more tactical refactorings there. We can add in listeners to data here. So when something changes, we use observer pattern to fire a notification. Then we can have something which is monitors those notifications. It serializes the changes and it creates an ordered flow of change events. And this is very important. This is really useful, very important, and something which we do make a lot of use of, and we'll come back to this. So splitting the IDE, where do we start on this? IDEs are complex. They're big applications which do a lot of things. They can work with a very large amount of data. You can have huge projects. You can have thousands of files, large files in themselves. You've got indexes and a whole load of data that needs to work with. Where should this data live here? Do you want to sync files to the local machine, use some sort of rsync type of thing? Do you want to leave files on the remote machine but sort of sync indexes and do some work on the client to be able to work with that? Or how does it work? And it feels like you're going to have to pass around a whole lot of data, and this could be very expensive. And is this something that you really want to be doing? And it turns out that we've actually got a bit of experience doing something like this and splitting an IDE, and that's with JetBrains Rider. And if you're not familiar with Rider, it's our .NET IDE, and it came out of work which we did with ReSharper. ReSharper is a .NET, a plugin for the .NET languages. It plugs into Visual Studio, and so it doesn't provide its own UI. It uses a lot of Visual Studio's own UI. We wanted to make this into a standalone IDE. For various reasons. We wanted to support cross-platform, for example, and we build IDEs. The IntelliJ platform is there for building IDEs, so it makes a lot of sense to use that. We can get a lot of features for free by reusing the IntelliJ platform. But the problem here is that IntelliJ platform is JVM, whereas ReSharper is .NET, and so we can't have those in the same process. We have to split them apart. So we've already got an IDE which is split. And we kind of joke about it being a microservices-based IDE. We've got multiple processes for the UI, for the language processing, for the debugger, for external analyzers, and we have to talk between them all. And as part of the work with Rider, we created some inter-process communication, which is based on hierarchical, observable, stateful models. So we looked at various sort of RPC request-response methods there, sending JSON across there, and that wasn't what we ended up going for. We found that it was more effective to describe the view of the data that the front end needed and describe those into observable models. And you can then sort of synchronize that across the network, well, across the local host network, loopback network, that's the word. And you can then observe the changes, you can react to it, you can push data, and both sides can react to this state. And we've got a very good model working with Rider there. And it's interesting to point out as well that the remote development and collaborative tools team came from Rider. So looking at this idea of having a split of a JVM UI and a .NET backend you can imagine the questions. What if the front end and back end are on different machines? That's remote development. What if there were multiple front ends? We can have collaborative. So you can see how the work that we've done has come out of the work we did with Rider. So how how does Rider split the IDE? It uses the IntelliJ platform as a UI for sharper language analysis and features. So the platform provides a whole load of foundation that we can reuse and we can provide implementations for. So Search Everywhere is already implemented by the platform. We just need to provide the data for it. Same with Find Usages. We just need to provide the data for it. And that's what Rider does. It implements these APIs by delegating to ReSharper. It also gets to reuse some existing language agnostic features such as version control, web tooling, databases, and it gets all that sort of information for free. But the reason it can do this is because all of the data is local to both processes. Gateway doesn't have that luxury. We can't use language agnostic features because the data isn't local. We can decide to put the data local, but it's not there right now. One of the things we said for remote development was that we want to be able to put the IDE, the source code, toolchain, everything on the remote machine. So all the data is remote by default, unless we sync it. And if you want to do version control, for example, that means you're syncing practically everything. So you're kind of losing some of the benefits there. So the decision is mostly made for us there. Data is remote, the features must be remote, but we want the UI to be local. So we split the IDE at the UI layer and we build a thin client. But look at that. That's a big IDE. There's a lot going on there. We've got editor full of text, full of syntax highlighting with warnings. We've got tool windows. We've got lots of different tool windows going on there. We've got toolbars. We've got version control. There's a lot of information. So how do we do with it? How do we do this? How do we work? Well, the key thing to think about here really is that the UI doesn't need to know everything. It can be a dumb or thin client. So the user only ever really sees a subset of the data. We don't have to sync everything. We just need to sync enough information to show what the user needs to be able to see. So an IDE is complex, yes, and it can have very busy UIs, lots of tool windows and things like that. But the visible content and the visible changes are relatively small. So for example, if you are typing something, you tend to make small changes in a document, and the document then updates the highlights and that within the method that you're working on, for example. If you're going to show a pop-up like QuickDoc, that's just a small block of rich text. So again, it's a small bit of visible data. Compiling is a big deal. You can spend hours compiling a massive project there, but everything happens server side. All that you need to show on the client is a progress bar or maybe even a text output log. Same with switching branches. That might affect thousands and thousands of files, and it might cause lots of re-indexing. It might change the project view completely. It might change all the dependencies completely. But the only effect on the client is going to be the name of the branch on the UI and perhaps the project view updating. So these changes can be quite small, even with very large changes to the sort of structural changes. And on top of that, then the UI, if we look at the UI, it's complex, yes, but it's also hierarchical. So we could break it down there. We've got lots of common repeated features. So there's toolbars. If we can handle one toolbar, we can handle all toolbars. If we can handle one tool window, we can handle all of them. If we can handle one editor, we can handle all of those. And we can break those items down sort of semantically as well. So a toolbar is just a list of actions. And the action is a bit of text, an icon, a tooltip, and a callback. The editor, you can break that down as the text, the location of the caret, the text cursor, the ranges of highlights, gutter icons, and so on. So we can implement support for these types of things and then sort of scale that up across features. And it allows other features to come in that use those things. If we add a new toolbar, we don't have to add extra functionality for that toolbar. It just comes through. So how does Rider deal with this? Rider built what we call the RD protocol, and it was stood for remote development at the time as well. So now it's kind of confusing that we've got remote development elsewhere, but that's just adds to the fun. And this allows us to create a hierarchical observable collection of models. And the models are automatically synced to both sides. and you can push data from both sides, and you can subscribe to changes from both sides as well. So this is great. From the front end, we can push some data on, and the back end can subscribe to those changes and react to it. Like if I enter text into a text field, it can run something as a callback. If I want to do something in the other direction there, I can get something. I can push results into a list, and the UI can subscribe to those changes and display them. So we work with view models rather than domain data. And we can, as I say, we can sort of scale this out then for like toolbars. We can create common view models there, which describe a toolbar, which can describe, there's the items that are in a toolbar, the items that are in a pop-up, such as the Alt Enter menu there. We can have a pop-up menu of text icons, whether there's a sub-menu or not, and then a subscription for when it's selected. This observable pattern works very nicely in these cases. And then we just need to put it all together. We've got what we call the synchronizer in remote development there. We subscribe to listeners from the platform API. So remember that I said that we could make tactical changes to some of the synchronous APIs to allow us to have observers and listeners. And when those change, we update the models, get synced over the protocol, and then the UI can subscribe to those changes and update the user interface. And we can do that sort of in return as well. The backend, the server, can subscribe to changes and use that to call into the platform API. And one of the nice things about this is that it can actually act as a nice thin layer on top of the platform API. So it's kind of non-intrusive. We don't have to rewrite the platform API in order to work with this there. So we work now with a set of reactive models. And as I mentioned before, we kind of can make a list of ordered change requests. So that's all well and good for the UI. We can sort of describe some toolbars and things there. But what about the editor? The editor's a bit more complicated, isn't it? An editor is a bit of a complicated beast. Well, one of the nice things is if we're building a local client, and if we are saying that we're going to have these sort of view models on either end there, which sort of describe the user interface and the data required for the user interface. It works well if we've got a common platform there, and we are actually using the IntelliJ platform to build the thin client that we use for both gateway and remote development and Code with Me. And the IntelliJ platform already comes with a pretty good editor, and let's use it. Why not? Instead of having to build an editor where the UI is kind of split weirdly across the front end and the back end there, we can have everything so that the editor works locally. We can easily sync the initial text, the caret location, the selection, the highlights, the gutter icons, the fold locations, the inlay hints, and we can use that state to replicate the editor. And so we can easily make another copy of the editor, which is being displayed locally there. And so you type locally, those changes can then get sent to the back end and processed remotely. So as the changes happen on the remote, as the remote machine gets these changes, it can process, do normal sort of the normal changes it would do on the back end. If you were running synchronously, to look for new syntax highlighting, errors, inspections, pop-ups, or for quick documentation or completion lists and everything, and these will then get sent back to the front end. So there's a lot we can do there with a local editor and a remote processing. But the remote processing requires a network call. But we've got a local editor. So we don't need to wait for that network call to complete. So we can, that server doesn't have to manage how the editor works. It doesn't have to say, okay, I've received that text, now move the caret on one character, or you've hit return, move the caret on to the next line there. We don't need it for that level of support. We've got a local editor. So we don't wait for the server to reply. We just keep typing. We do, we have optimistic updates. We expect things to work well and to carry on. You just keep typing. And this is good for latency, obviously, because It improves the user experience. It feels like a local editor because it is a local editor. So that's great. And because of that, you can also customize behavior as well. So you can even install the IDEA Vim plugin on the local client to radically change the way that you interact with the editor. But as far as the server is concerned, it doesn't matter. It's still getting text changes. It doesn't care quite how you make those text changes. It just cares that they are happening. But we can still have issues with conflict resolution. Even with a single person, with a single user, there is a chance for conflicts. If we're typing while waiting for the server might change the text for us, which could then put us all out of sync. So a good example of this is the typing assist. If I open a bracket, the IDE can insert a bracket for us. If I invoke the statement completion command, then the server inserts the text for me. But by the time that the server, we've sent a message to the server, and by the time that the message comes back again, I might have typed another couple of characters. And so if I insert an open bracket at offset 10, the server wants to insert a close bracket at offset 11, but I've already typed a letter there. So there's already something there. So we've got a conflict. We must be able to resolve this. And the way this works is really rather nice and smart. And the client maintains an ordered queue of change requests, and it sends these to the server serially, one after the other, and the server decides whether to apply or reject them. And then depending on the results of that, the client will either send the next change, or it rebases the queue and tries again. So it will kind of roll back to a state and reapply all those changes. So when the server sends back a message saying, here's your closed bracket automatically inserted, we can roll back and insert that closed bracket and then reapply the typing. And everything works as expected. If we want to take a look at this in a little bit more detail, we can look at a diagram which has got very big arrows, which not quite the plan, but we can ignore the big arrows. And if we look at this now, this is kind of the process of what happens when you type. So the user types the letter and two things happen. Firstly, we insert the text in the local editor because we're doing optimistic updates and we think it's going to work. We then also have the request engine, which creates a new request, a new change, which is going to be added to the queue and then sent to the server. So the next item will get sent to the server. The server itself receives this request, it checks versions, and then it applies the change or rejects it. Now, checking versions is something which I haven't mentioned yet. But if we have a look at this now in a little bit more detail, when the server receives the message, the change contains the version of the document as it stands. And the server needs to check that the client is working with the appropriate version. It's got the message that it expects, things haven't got out of sync, and everything's good. So as long as the versions match, we can apply that change on the server and send the results back. The server is the source of truth. The server owns the files. This is applying that change to that file, and we're saying we accept it and it's good. If the versions don't match, that means that the file has been changed and the client doesn't know about it. This might be because there are multiple users. There might be because there has been a change by the server or whatever reason there. However, it can then send a reject, and the client then has to deal with that. Now, we've got a box here as well, which is we apply the changes and then we send results. Those results might include extra text, so it might include our close brace there as well. And so when we get back to our client, which again has big arrows, we see that the client receives the result from the back end, and it's either a success or a failure, a rejection. If it's a success, we've got our actual results there. We apply those and we insert our closing bracket, and then we send the next typing instruction there, and the whole process carries on again. If it isn't a success, if the call has been rejected, then we roll back all of our queue of pending changes. We undo all those changes, we apply the actual results which have been sent to us, and we said the server has said, nope, that's wrong, I'm not accepting that. This is the current state of things. So we apply those states, and then we redo all of our pending requests. It's like rebasing. We kind of effectively roll it back, get the state back to how it was, and then reapply the changes. So we know that they're changes. It's like typed a key, it added a character to the selection and moved on, and so on. And once we've done that, we then update and carry on. And so again, the process should sort of just repeat and carry on doing it, and we will get through all of our changes serially in order, and we will hopefully avoid all these conflicts and work nicely. So that's great. That's looking at it from a single user point of view. But what if the other machine, if the remote machine was someone else's desktop? This is working now with multi-user. So can we host multiple users concurrently? And it's like, well, yes, we've just got a nice, lovely conflict resolution stage there. And it works for single users, but you can see how we could extend it easily for multiple streams of changes as well. We process the incoming streams serially, one after the other. And every time there's a change, we just check that the versions are correct. We check that nobody has updated it unexpectedly. And if it has, we just send it back, it rebases, and we get an updated change as well. So whenever a process comes in, it gets applied, and the results of that get broadcast to all of the clients. So if we've got several people joining in a session, all of them will get the result of that typing. So they get notified that new characters have been inserted. The clients can then rebase their pending streams on top of this and try again with their next message. And all of this then works in a sort of nice conflict-free way. There are some other interesting problems, though, with multiple users. We start to increase the amount of state that we have to keep, and we have to keep track of state per user. So if you're working just by yourself in an IDE, you're going to have your currently open editor, and you're going to have your list of open editors. These are the values that the inspections tend to run on. It's where your text cursor is, it's where your selection is, and so on. We now need to keep this for different users. And then when the server is actually running processes, it has to sort of join these all together. So there are various points where we have to know in the IDE itself that things can be used by multiple users. As a surprising one, which you perhaps might not think about, is the undo stack. That has to be per user as well. And it's obvious when you think about it, because if there are two of us typing in a file and I try and undo something, I don't want to undo your change. I only want to undo my own changes. So it's important that we kind of keep that as a separate state as well. We need to keep some settings, such as filters in various pop-ups. If I'm filtering usages by filtering usages by read usages or write usages or whatever, then I want to be able to keep those per user. We also then have active pop-ups such as completion and so on. We don't want to mix those up between different users. We don't want to share completion per user. We want it to have individual ones as well. And then another one which might be per user or it might be per per session is tool windows. So tool windows, I might want to have a shared tool window which everybody sees the same thing and they will see the same selection and so on. Or I might want to have my own view of it as well. So the project view, for example, is a good one here, because we would probably want to have your own project view yourself so that you can open up the files. If I'm trying to navigate to a file and somebody closes the selection down, that's not going to be no good. I want to be able to have my own view on that. So again, some tool windows can choose to be per client or per instance, per IDE, effectively. But then this increases the state that we've got working on there. The next thing that's important for us, though, is per client activities, and that's who to send the replies to. So many activities are async and per client as well. So code completion is a good example of this. We want to start the completion process. We have to go off. We can go to the background thread, collect all the items, come back to the UI thread, and notify the user. On a single user interactive IDE, this is great because that's fine. You just show it on the UI. But if you've got multiple users, how do you know who the completion is for? The client sends a request, the server processes it asynchronously, but who is it for? And the way we do this is that each client has a client ID, which must follow through the flow of execution. So when the request comes in, the request is tied to a client ID. It goes off into the background thread. The client ID has to go with it. And then when it comes back with the completion results, we get a client ID and we can know what to do with it. We can show it interactively on the UI thread, or we can send it back to the correct Code With Me client. This is something that has to be built into the platform. So this is something that the platform knows about, but it knows at again, at a fairly non-intrusive level. So this is stored as a kind of thread local value, but it's a thread local that travels with the flow of execution. So if we are using threading constructs, if I put something onto a background thread or start a Kotlin coroutine, then this automatically from the platform gets passed around with me. So on the for the most part, I don't need to worry about this, and it is handled for me. So again, nice, non-intrusive, no giant rewrites. The client does it for me. Okay, so nearly finished now. Couple of last things to clean up. Complex UI. So we've talked about like toolbars, the editor, menu items and things. Those are all fairly simple and straightforward. But if we look at the UI there, there's actually a lot going on there. We've got a couple of tool windows. They've got content. There's a diff view as well, and there's a lot of things going on there. So how do we deal with this, and how does that work? And again, we use our RD protocol, our protocol of observable models, and we create a model of the view. So this is really quite smart. We've got a way of doing this within code. We've got a DSL, a Kotlin DSL for describing a view, which has got panels, it's got rows, it's got buttons, drop downs, text fields, and so on. And we can serialize this in our observable model over the protocol to the client. The client can view that and just very mechanically recreate that using native, using Swing APIs. These observable properties give me callbacks, so I can, like a text field, for it changes, it's observable, it gets automatically passed over to the server can process it. But the downside to this is it requires rewriting the UI. And so we've got a really nice way of doing this. I do love this feature there, is we can transform this UI, we can do this automatically. We can walk the Swing hierarchy and transform that into a model and synchronize it. So generally speaking, UIs, especially if you're talking like settings dialog, for example, there's a fairly straightforward UI. It's going to have a panel. The panel is going to have rows. A row is going to have a button. It's going to have a text field. It's going to have a drop down. There's going to be another row which has got a button in it, and a row with a text field. And so it's quite mechanical, and we can do this. And as long as we understand how to work with a particular Swing component, text field, button, so on, we can then transform it, and we can then put that over the wire, over the protocol, and then recreate it on the other end, which is very convenient. But sometimes there's some UI which is just too complex to sync in that way. If we don't know those particular Swing components, or if the Swing components are particularly complex, then we can't really do much about that there. And we're going to have to migrate that to, we're either going to have to teach the protocol how to understand that, or we're going to have to migrate that to APIs which will work with the collaborative tools, with remote development, rather than just working at the Swing level. And some of these can be, complex UIs, sort of some grid views, some things which have got very custom layouts so that we don't understand what the Swing layout is going on there. Jupyter notebooks in the editor is a good example of these right now there. And the way we work with these is to bring back Projector. So as I say, it's a fantastic piece of technology, but it's not something that we want to use to do remote desktop effectively of the whole UI, but it's really quite useful in this situation while we're migrating things to provide a view of a subset of the UI. So we can actually use Projector to project a tool window or project a dialog and rebuild that on the other side there, which is really very smart. And I do like this feature. It's really cool. And it's as I say, it's something that we prefer not to use because there's the latency and the network traffic involved is not as good an experience as using the view models. However, it is a good compromise while we start to sort of migrate things. So where does this leave us then? How do we make a 21-year-old desktop IDE remote and collaborative with a lot of smart ideas, basically? And I do have to give a shout out to the teams behind this. There's a lot of nice ideas and implementations to make this work as seamlessly and as effectively as it does. It's really cool. Learned a lot from Rider, which itself is very successful and very sort of stable and works in a fantastic way. And the way it does work is, it kind of builds up from building blocks, really. So if we can sync UI building blocks, we can scale that up. If I add one toolbar, I can add all toolbars. If I add one inspection, I could add all inspections. Implementing the editor locally is great because we get to have the feeling of a local editor, but we're still with all the remote processing going on there. We sync change events as a flow of events. And we support conflict resolution and rebasing to allow us to try and keep everything in sync, working with multiple users, and also the typing assistance and refactoring that comes from the IDE itself. And the other big change then is also that the platform itself knows about a number of these features, tracking the client ID automatically through the platform API and allowing us to use it if we need to use it. So what's next with remote development and gateway? We want to continue covering all of the platform UI. So we want to, sort of try and reduce the projector usage that we've got going on there. We want to support more subsystems and different IDEs. So we don't support Rider currently, for example. And one reason of that, which is a little ironic based seeing how everything comes from Rider, one of the main reasons for that is that Rider's conflict resolution is different, and so we kind of have to now marry up two different conflict resolutions strategies, which is really quite complex. But that is a work in progress there. We've been working on supporting Rider for remote development, where you've only got a single user. That's working nicely at the moment. Again, still in progress, but still available to try and to use. We're looking to support Code with Me as soon as possible. We want to ensure that all APIs are remote and collaborative by default. So we want the new stuff that we're building now is suitable for working with remote and collaborative scenarios there. So we want to make sure everything is sort of complementary in that manner. Basically, the next line is saying the same thing from a different point of view there, not just that the APIs and the platform support this, but that the feature sets support this as well, so that we think about remote and collaborative scenarios when we're designing scenarios. And then, of course, there's feature roadmap, of course. So collaborative remote development, Code with Me within Gateway. Okay, and so that brings me to the end then. Thank you for watching. If you would like to try it for yourself, it's built into IntelliJ IDEA. If you've got a license, you can try remote development. You can try Code with Me. You can start a Code with Me session there. There's a couple of links there, jetbrains.com/remote development and Code with Me, which will give you more details. And down the bottom there, there's a short link there for a video from my colleague Martin, which is describing the sort of microservices behind Rider as well, and a little bit more about the Rider protocol, which sort of underpins all of this. And so thank you all for watching.
Amazing. Thanks, Matt. I probably should have thought about it, but I didn't think about it until now, just how much work and effort has gone into to that split, for want of a better word.
Yes, it's really cool, and the team deserve a lot of kudos for it.
It's mind blowing actually. When you were describing some of the states and the queues, I was like, oh yeah, of course it works like that. How else would it work? But yeah, there's so much going on there. That was amazing.
There is. It's busy, but it's good. And
it is awesome.
And yeah, try it. It's the end result is really, really good. So everyone should give it a go.
I have. I'm just going to remove your, as hopefully everybody's taken note of that. I should remove that from the screen. But yeah, that was absolutely amazing. Lots of great questions in YouTube as well. Our YouTube moderators have, again, been fantastic and incredibly efficient. So thank you for that. We're upwards of 15 questions, including compliments such as such a clear explanation of a complex topic, which I wholeheartedly agree with. I guess isn't it down to me for my questions then? I use Code with Me in my day job, as you clearly do as well. What's your favorite feature or thing about Code with Me?
I really like the follow modes. The follow modes are really cool because it allows you to work with different sort of scenarios. You can go off and do your own thing. So, one of you is working on tests, one of you is working on the production code, and you can click a button, and then I'm following you again. And I can say, well, okay, I'm lost. I don't know how to do this. And you say, well, I'll show you. Follow me, and you can sort of step through a whole load of APIs and explain stuff, and it's great. Or I can say, okay, my turn. I'll take over. You can follow me and work with that. And it's a great way for doing different scenarios, such as, mentoring, code reviews, teaching, and all sorts of stuff.
Yeah, exactly. I'm the same, especially when I'm working with somebody who's much more familiar with the code base than I am. It's nice. You can almost kind of hitch a ride, can't you? Be like, okay, I'll just follow you around and get a feel for things, and then they can show you stuff, and you don't have to worry about going, to Command D or recent files and just trying to find the next topic that they've actually jumped to, which is interesting.
Yeah, absolutely.
Our YouTube moderators are just on it. There is a question that's just come in. I don't know if it's being answered, but I'm going to go for it anyway. Can you? It has been answered. You see, they're just too good. They're just too good. All right.
I'd have got it wrong anyway, so it's fine.
We've got a minute left, Matt. Do you have any closing thoughts that you'd like to share with our audience today?
Only to try it. I mean, these products are really good. They are very smart under the hood, but they're also really good. I mean, and there's just so many features which I haven't been able to talk about as well either. There's voice chat, text chats, and everything in Code with Me, so you can collaborate nicely there. I love the port forwarding, the automatic port forwarding for when you're running and debugging in remote development. It's probably worth pointing out as well, remote development is really best for web applications right now. So because obviously you're running remotely, so it's hard to run your desktop application remotely and usefully debug it, usefully test it and interact with it. But working with web-based applications can work really good. Yeah.
We'll take it.
Yeah.
Good at English. I would second that. I love Code with Me. It's a game changer, actually, and I really enjoy working with it. Use the video and audio functionality all the time as well. So definitely give it a go. Matt, thank you so much for your time. Thank you for joining us today, and take care.
Well, thank you for having me.
All the best. I'll remove you.
Thanks. Bye bye now.